So good afternoon, everybody. Those of you who are just joining us, we're just waiting for the few remaining registrants to come into the room. We're watching our numbers frantically. So welcome to those of you who are already here. We're on our 6th weekly webinar of our autumn series. Thank you very much for taking the time out to come in and join us today. Just very quickly, before we launch into today proper, for those of you not familiar with OCCA, just want to give you a very quick introduction as to what it is that OCCA does. So as a professional association headquartered in the UK, we have individual members from around the world who are employed in any capacity in the world of coatings and allied industries. And currently we have just over 800 members, the bulk of whom are here in the UK, in South Africa, in Australia, New Zealand, and also a subdivision in Canada. We have ordinary membership and professional membership, and an increasing number of students joining us. In terms of what do we do? So we try and be the link between academia and industry, and we nurture and encourage training for individuals in this surface coatings and colour world. We do that by way of educational seminars, our weekly webinars. We offer visits to companies. We run symposia, and we have networking events both on a social and also on a business level. We also have introduced some new bursary schemes, and we're working very closely with some of our partner universities to try and ensure that those bursaries are offered to students who want to further their studies in colour-related disciplines, or to individuals working now and doing day release part-time with their employers. So in terms of our main reason for being, our Surfex exhibition, which many of you will be familiar with, currently Surfex was delayed from this year into June of next year. And at the moment, our plans are still, if we can, that Surfex goes ahead in June. So over 2 days down at the Rico Arena in Coventry, we have some 120 exhibitors, and we have usually between 1,000 and 1,500 visitors over 2 days. It comprises webinars, seminars. There will be a careers fair for new students. There will be showcases for universities there, and also the regular exhibition format that many of you are familiar with, and also a networking event on the first evening. We also have a journal that we publish 6 times a year. So with a new team installed earlier in the year, SCI Journal has had a revamp. We have a new technical editor on board. So this offers you insights into industry news, appointments, technical articles, product showcases, and other advertising and events with the coatings industry. We have a partner scheme right now, and I'm delighted to say that X-Rite are one of our very valued corporate sponsors. So thank you very much, X-Rite, for supporting OCCA in the way that you do. We also have partnerships with 4 universities currently in the UK. So with Lancaster and Leeds, with Salford and with Warwick. And we are trying to foster these links with students coming out of the universities who, let's face it, should hopefully be the colour chemists and the coatings chemists of the future. So without further ado, enough about OCCA. Let me now get on to today's real reason for being here. So I'm delighted to introduce Colin Wakeford, who is team leader, applications engineering North Europe for X-Rite. And Colin today is going to talk to us about cost-effective quality control for effect colours. So Colin, over to you. Thank you.
Thanks, Anne-Marie. So yes, cost-effective quality control for effect colours. Just before we start, the session will be broken into kind of 2 rough parts. The first part about instrumentation and the second part about software. But just as a sort of broad introduction, who X-Rite Pantone are. X-Rite was formed in 1958. its first product was actually X-ray marking tape, which is where the X-Rite name comes from. It then moved into color measurement, both in terms of instrumentation and software. We jump forward to 2006, it merged with Gretag Macbeth, which itself was a merger between Gretag and who were more into densitometers, and Macbeth, who many people know through the legacy of spectrophotometers, and of course Munsell Color, which was part of Macbeth. A year later, acquired Pantone. So the X-Rite you see today is the culmination of the legacy of X-Rite, of Gretag, Macbeth, Munsell, and Pantone. So a full range of products across all of color measurement and color control. Today, we're owned by the Danaher Corporation, which is a large American corporation with a quite large number of different companies in life sciences, diagnostics, and applied solutions. A lot of these companies this year have been very heavily involved in work towards COVID vaccines and also testing. We're in the product ID side of things, along with companies such as ESCO and Videojet, which are involved in similar areas to ourselves. Our worldwide headquarters is in Grand Rapids, Michigan, and we have an EMEA headquarters in Reykjavik, which is the old Gretag Macbeth, although Gretag headquarters and the old Gretag Macbeth European headquarters. We have sales offices here in the UK in Manchester, also in Germany, Italy, France, Spain, Far East, China, Hong Kong, Japan, over 600 staff worldwide. And we offer color solutions in every potential and maybe some potential we hadn't thought about industry, color manufacturing and using industries, automotive, paints, plastics, textiles, print packaging, cosmetics, food, and the list goes on. Keeps life very interesting. So on to the main topic of today, why affect, well, let's start with a bit of background to it. Why affect pigments at all? Many of you who are listening and tuning into this will be well aware of that because it is you work in. In the automotive industry, apart from the model, the most important factor in buying a car is the color. The 1920s saw the first use of color to reflect our personal tastes. I think before that, it was really the Henry Ford model. You can have, or philosophy, you could have any color as long as it's black. The 1930s saw the first use of metallic paints, originally made from fish scales, and it was very expensive. So it was only the rich people who could afford to have metallic finishes. The metallic finish showed off the curves of the body shapes. So it's very much seen as a shape enhancer. So you can see from these two images, white BMW on the top there, but then when you give it a silver metallic finish, you really begin to see the curves on the body shape much more clearly. Obviously, effect pigments give us a much greater variety in colors. For example, how many shades of black. We have one customer who said to me a couple of years ago, he said, well, you know, there's not just one color of black. We have 50 colors of black. And, you know, it's true. Once you put some metallic finishing into a black, you can get all sorts of different nuances within that. Black and silver metallics are the most popular at the start of the 21st century. So just as well, there are so many variations of each. And black, you know, if you're in luxury and SUV models, it seems to be the most popular colors. Dark metallics, the most dramatic to look at, but are prone to showing up nicks and scrapes. And so, yeah, maybe they're not so, you have to look after your car. So if they're more prone to wear and tear, you've got to make sure the color matching and the color touch-up is, or color matching becomes more important in those areas. So to take a very simplistic view of a metallic finish, if it was a solid color, we'd be shining light onto that film. We'd have light reflected off the surface to give us our gloss or our semi-gloss or our matte finish. The light that is absorbed into the layer will, depending on the nature of the pigmentation within there, some wavelengths of light will be absorbed and some will be reflected. in a very simple first generation metallic, you put aluminium flake in there and you get reflection of that, so you get a sparkle effect. Obviously, pigment or metallic and effect finishes have moved on greatly since then. You have pigments, some of which are coated on one side to give different absorption characteristics, and there are xerylic pigments and a full range of other effects going from one color to another, or just giving general sparkle effects. If we look at the actually evolving color design and how it's impacts the need for color control, if we look at Volkswagen Golfs here, back in the 1990s, on the left side of the screen, the designers very helpfully put a nice black plastic strip around the car. And so there's a lot of separation between different color parts like bumpers and wings, which meant our color control could be a little bit wider, because the moment you get two colors that are not butting up against each other, the quality control and the color becomes a little bit wide, or we can make it a bit wider. But then we move on to current models where the designers have decided in their wisdom we're going to have zero gap technology, where everything else is butting up against everything else. So you have a plastic bumper with a paint system on it, and you have an aluminium wing with another paint system on it touching. So your color control suddenly has to be that much tighter. And so the need for color or accurate color measuring devices becomes much, much more important. For example, here's a car wing with a nice black strip applied. So we have two colors, and you can possibly see there is a color difference between the two. It might be open to subjectivity, whether that's an acceptable color difference or not. If we take away that black strip, we suddenly see that is quite a noticeable color difference, and probably something we wouldn't really be wanting to accept if we were buying an expensive new car off the forecourt. If you're going to buy a second-hand car, you might look at that and think, there's been a bit of touching up going on there. Maybe I won't buy this particular model or this particular car. I'll go and look at something else. So, instrument geometries within multi-angle measurements. If we look at a metallic panel, if we look at it at one angle, we might see a particular color. We look at it at a different angle, it might change. It might become more glossy, less glossy. If we're looking at two panels side by side, again, if we only view them in one particular direction, we might get a good match, but then we move or view them in a different way. Again, if you walk around a metallic finished car, the door might suddenly not match the wing, or the wing might not match the bumper suddenly as you walk around where it did at one particular angle. So we need to measure a number of different angles. So what in this schematic we're showing is a number of different illuminants shining at different angles onto the sample, and we have one pickup or detector. Now we talk about gloss angles as being, or the angles of measurement being the angles away from gloss. So this each of these lamps is shining on at a different angle, and the angle of reflection will be equal and opposite to the angle of sorry, I forgot the word. Angle of incidence is what I was looking for. So we're detecting away from that gloss angle. And these angles I'm showing here, the 15, 25, 45, 75, 110, are actually comply with the DIN 6175 German automotive standards. So as I mentioned before, the different types of metallics, obviously a straightforward metallic just enhancing the gloss or the specular appearance, the shape enhancers. Then we have mica and interference additives, and then we have pearlescent finishes, amongst others. So kind of going back to the point I made a few minutes ago, if we view with a standard 45-degree angle of view, in illumination and a 0-degree detection, we see a color, maybe it looks like this. But if we view it at different angles, this is the kind of effect we can see. So this is, in this particular example, we need to have color measurement at all of these 5 angles in order to make sure that we're getting a good color matching or color agreement at each of these, from standard to sample or panel to panel. So within the X-Rite range of spectros, looking a little bit at the timeline here. Firstly, let's go back to, this is actually from when from before X-Rite kind of brought to X-Rite Greta Macbeth into the fold, the MA-68, 2003, a 5-angle instrument. We then move forward to the MA-9X series from 2010. This goes from the MA-94, which is a 5-angle kind of equivalent to the MA-68, the MA-98, and then 96 and 98, which includes up to a grand total of 8 angles, outer plane measurements, number of detectors, giving up to 12 angles of data in total. And then we jump forward to the last 2017, where we introduced the MAT6 and MAT12, either 6 illuminant or 12 illuminant instruments, which also had an RGB camera in it to capture sparkle, which was something we hadn't managed to do in our previous generations of instrument. The reason for talking about this, leading us on to the instrument, which is the focus of today's presentation, the MA-5 QC, is that the MA-5 QC uses the technology which was pioneered with the MAT6 and 12 instrument. One of the things we found when, like, for example, the MAT12 came out, very high level, high-end instrument, giving a lot of data, great for a research and development lab like pigment manufacturers or people wanted to develop effect finishes in a number of different applications. But, you got a high-end price, a high-end spec, a lot of data. Is that what the auto repair shop needs, where a lot of the operators might be using it as a tool, as only part of the many tools that they will use in the auto refinish? So we need something that is going to give us the maximum amount of information to meet their requirements with a much more user-friendly, simple-to-use interface. And if we look again at the DIN 6175 spec, they are specifying the 25, 45, 75, 110 degree angles. So if you go above that, yeah, there's a lot of information which different manufacturers can glean a lot of useful information from, but it's overkill for the auto repair shop. So if we look at the spectrum of color versus sparkle, which is something we were looking, as well as our competitors, to kind of cover the whole, encompassing for all the texture from sparkle through coarseness and the flakiness, through achromatic, chromatic, and multicolored finishes. I'm kind of working the opposite way around here. The MA-5 QC covers the 4 bottom left-hand squares. The MA-98 gives them into the multicolors, and the MAT12 gives us the full spectrum across all of these. The RGB camera helping with, as I said before, with the sparkle. So to give our 2020 MA solution, we have the MAT, as I said before, high-end appearance instrumentation, which is giving sparkle grade, coarseness, 12 angles of data, good for a research environment. Then we have the MA-5 QC using the same technology, but providing data at 5 angles with very easy to use onboard software, which we'll come back to in a second, and the EFX QC cloud-based software. So the MA-5 QC can be used as a standalone instrument to do quick pass-fail measurements, but when it's linked to the software, brings in things like jobs, more data collection and display functionality. So a little bit, well, to focus now on the MA-5 QC, it has a single detector at 45 degree angles, similar to the schematic we saw before, 5 directional LED illuminants. So white illuminant, spectroanalyzer giving us 10 nanometer interval data across 400 to 700 nanometer, high measurement precision, and again, using technology which was trailblazed 3 years ago now in the MAT series. Embedded calibration, so you don't need to do calibration with an external calibration tile on as regular a basis. Now it has a 30-day calibration interval with the external tile, and then it has an internal calibration which operates on a daily basis. The instrument itself, if you look to the bottom, it has a cover over the detectors and the LEDs so that you're not getting any dust. You know, an auto repair shop can be quite a dusty environment to work in, so just giving the instrument a bit of protection. It is also kind of touched on a later slide, but it is USB connectivity to the computer, but USB connection is also the charging point for it. It does have a separate charging port, but if you're using it in without that, it is simply USB plug into the computer and it charges as well as being a live measurement head. There's also a temperature sensor built into the instrument, which also displays temperature when you make a measurement. So you can record this to make sure that, or to analyze whether temperature is having an effect on the color measurements you're making. And let's say with the LED illuminant, which like everything else is a bit lower powered than traditional tungsten or xenon lamps, you get about 2,000 measurements per charge when it is used totally separate from the PC. So here you can see it's a small, lightweight instrument. I have one here that if the technology in my background doesn't fail me, there's an instrument, very easy to use. I'll come back to the screen in a minute. It has woken up. Oh, although, yeah, technology is not showing the screen at the moment, but it is very simple. So one-handed instrument. You can see there's the port at the bottom with the shutter over it. So onboard touchscreen technology software, so you can operate the whole thing hands-free and get into difficult shaped parts on the car. And the optics are at one end of the instrument rather than the middle, so it's easier to position. It has 3 touch sensors, which I can maybe show you on the screen there, which make sure that we have good contact on curved parts like a wing or a bumper or whatever. Okay, let's my presentation seems to have for the second frozen. Give me a second. So here's the main screen. On the instrument, we can see we have the calibrate option. Again, this is all touch screen. Power on and off. It's Wi-Fi compatible as well as the USB. We found that Wi-Fi is better than Bluetooth. It gives a more reliable signal. We have a basic measurement screen, which allows us just to do data capture, which we then can come back and download into the software to do more with, or we can do a quick compare where we measure a standard measure trial and then get our color difference at the 5 angles. Job template, which we can create in the EFX software, which is like the second half of the presentation, upload it into the instrument, and then an operator can then follow that template step by step around the car, so that we make sure that the operator is using it is measuring the same parts in the same order. And then there's settings where we can set up things like the illuminance we want to use, the color difference equation, calibration interval, etc. As I said, 2 things there. One is the temperature sensor being reported on the screen when you make the measurement, and those 3 contact points, it will tell us on the screen whether we have good contact. If one of them is red, it won't allow us to do the measurement, so we have to make sure we get good contact. And then the side buttons to press will fire the measurement, and the LED at the top will tell us if we've got a successful measurement or not. So a small size, as you can see when I held the instrument up, 19 centimeters by 7.5 by 95. I think it's personally, I think it's a very nice instrument to hold. It's a portable instrument, very comfortable in the hand, very lightweight, one-handed operation. Left or right-handed, very visible screen. And I think for many of us, a nice reassuring bleep when it makes the measurement. So if you're in a busy, noisy environment, you know that the measurement, you might not necessarily have the eyes all on the screen when you're measuring something, but you know your measurement's been successful. So here's a bit of the specification data, which is just really covering what we've already spoken about. 5 angles, 3 pressure sensor for positioning. The measurement spot size is 12 millimeter, 2.5 second measurement time. Short-term repeatability, 0.02 delta E C-lab on, and then reproducibility, less than 0.18 delta E C-lab, which for a portable instrument is pretty good spec. Inter-instrument agreement, which is important again when you've got body shops, maybe a number of locations where you want instruments there, can maybe sharing data, you want good repeatability. As I mentioned before, 400 to 700 nanometer at 10 nanometer intervals. 2,000 measurements per battery life. I've talked about the size, calibration, internal and an external once every 4 weeks, 30 days. USB connectivity and charging and Wi-Fi. And the software is our current EFX QC software, which I'm going to move on to, but also our legacy X Color QC software. So if someone's wanting to replace one of our legacy MA-9X instruments with this, the software will run it, and then it can be put into an emulation mode to run with third-party softwares as well. So that kind of leads me on to the software side of things, the EFX QC software. So this is a client-based cloud or client-server cloud-based solution. It's specifically designed to give a workflow from the left to the right. As you can see, the buttons on the bottom of the screen here to allow us to create standards, create templates, create tolerances, either to use directly in the software or to send these templates up to the instrument to take away and work within the factory environment. As I say, the workflow for the menu, left to right across the screen, you have the first group, the orange ones, the administration apps, which allow us to observer browser, which I'll come back to, data access tool, property editor, which tags to give more information, which you can add to the standard. And then we have the editor apps, the real kind of everyday working ones, if you like, where you can create tolerances, create standards. And I do say create rather than just measure. As we'll see, there's a number of different pieces of information we can store together with that standard. Job templates, and then there's EFX QC and EFX QA. The QA just being able to look at multiple jobs and multiple data all at the one time over the QC, which is single template, standard versus number of measurements. So the object browser. So we can organize different attributes. As you can see here, I have a range of standards, which I've then put into a subfolder all of their own. I've then created tolerances, which I've filed under a particular tolerances template folder. So a number there. Then I've got templates and then configurations for the instrument and so forth. So it's something that you as an operator can make sure you've got a nice tidy housekeeping for when you come back to find individual data. I found great personal store in this. When I first started using the EFX software, I had stuff just stored in one folder. And then when you're trying to do demonstrations of this and trying to find meaningful standards to put into particular templates to use with certain tolerances, it wasn't the slickest of demos sometimes. So began to learn that an operator wants to be able to find this data quickly and be able to use it quickly. So tolerancing, if we want to, there's a set of 3 icons on the bar there, but also on the top line file, which allows us to open a template, a tolerance, or create a new tolerance. So we then, once we get this, in this case, I've opened up Delta CMC and it creates the date with an asterisk, which shows it's something I've created but not stored yet. I can then choose, again, what tolerance I want to use. I can then, if I've chosen it again here, Delta CMC, I have it at each of the active angles for the instrument, the 5 angles. I can then set individual pass-fail tolerances for all of those 5 angles. I can also create, as I have for the 110-degree angle there, I've put a kind of marginal limit on it as well. So that might be a more critical angle. So although I've set my pass-fail at 1 for all of them, I can say, well, actually, I want to know when I'm within about 10% of that on that particular angle. Or I could make that tighter tolerance, 0.7, 0.2, whatever it might be. Then for the standards, here, if I want to create a new standard, I can take my tolerances from that tolerance folder I have and drag whichever one or multiple tolerances I want into the left-hand box here. So I've got CMC. I might want to pull the DIN standard over as well, or you know, some other of the there's Audi Delta E's there in there as well. I can then, you know, if the instrument I can see in the top line, the MA-5 QC instrument is showing as active, so I have it connected and it's awake. So the measurement button is now open to me. I can make that measurement. So once I've got the measurement into the software, I can then see a nice little color curve of what it looks like across the different angles. I can see the reflectance curves and other colorimetric data. I then store this. This becomes all an integral part of the standard. So once I create a template, what I can do within this, I haven't actually done quite as many of my arrows and little bullet points as before. You can pull a standard into the top end of the box. There's a number of icons there. The target allows me to choose an individual standard, or I can choose a group of standards and pull them all in a standard library. I can then pull in tolerances, instrument configurations. I can then on the right-hand side create a display template of, in this case, a mini, and I can then place a number of parts or checkpoints within that car, so that if you're using it with the software, you know exactly what part of the car you have to place the instrument on. If you're using it with a template on the instrument, it will talk you through which parts, tell you have to measure a door or the roof or the petrol cap or whatever. Say once we then use that template, you can see here against the standard I've made a number of measurements. It's given me pass-fail very in the left-hand side of the display screen, very clearly against that. And on the right side as well, I can see the parts that have failed. I can also link two of those parts together. For example, the bonnet in the door. If I had a wing in there, it'd probably be a more realistic case. But I could then say, okay, my pass-fail is 0.5 CMC, but I want to make sure that the door and the wing agree within 0.5 of each other, rather than being at opposite ends of the tolerance and all agreeing to the standard, but maybe from a different direction, so that we get, you know, even better visual, because the petrol cap's at one end of the car, the bumpers at the other. So as long as, you know, they're within 0.5 of the standard, it would be visually acceptable. But if they're against one another, we probably want to have an even better match against those. So as I said before, you can create this template, and though you don't get this visual detail on the instrument, the template will operate in a similar way. It will talk the operator through which part to measure and then give a pass-fail result. So as you can see, this is the type of information we can have. It's telling me I've measured the part across it. And as you can see here, I have linked the bumper and the bonnet for two different cars here. In the first particular instance, it's failed. And in the second, it's matched within tolerance. So this is data we can measure on the Spectral away, again, from the PC, but bring it back, plug it in, and download the template back into the instrument, where we can get this much more detail, and we can report out the various aspects that we need to maybe put in an Excel spreadsheet or something else to copy internally or even externally. So we can see C-Lab plots with a nice little color background indicating what the color is at the different angles, but and we can also see straightforward LEB, delta E data on the right-hand side. Depending what we want to see, we can go into a single trial, job detail view. We can get just a pictorial indication of the flip and flop of the color across the 5 angles. So if that differs, we know that we probably got a problem when we're actually moving our angle of view on the sample or the car or whatever it is we're looking at as we move around. And we can see the travel within color space on a single color plot there as well. There is on the top corner, difficult to display this, but on the top right-hand corner of the display screen, we have a number of different icons that allow us to actually pop out other displays and other data and change the angles we want to see data on, rather than having to change the template on a sort of prior basis. So it allows us to do a quick sort of edit of the information we want to see. And as you can see on the bottom there, we've got that flip-flop sort of representation across the color. And these 2 examples, they are giving a good agreement, whichever angle we looked at it. So, coming to the end of the presentation now, I never know whether time just flies or I just talk quickly. Give more time for questions, I guess. So there's bringing together a summary of the total solution we can offer for the auto refinish area, or people who just want a quick, easy to use multi-angle instrument, which will give them data over these 5 angles. We have the MA-5 QC and the EFX software hand in hand. So, yes, I hope that has been interesting, food for thought, giving you some ideas, or some ideas for questions even. So I guess I hand back to Anne-Marie now.
That's right. So Colin, thank you very much indeed. Always lots and lots of information. You're talking about these machine names and software names and everything else, but this ties in really well. We had Dr. Trevor Sayer, who gave a presentation 3 weeks ago in our series about achromatic colours as well, and he was talking about all these effect colours and automotive. So this is tying in really, really nicely. So thank you for that. At this point, I'm going to invite Daryl back in as well. I know Daryl's here with us. And we're going to launch straight into this because we've already had some questions put to us in the Q&A. So Daryl, do you want to go ahead and read some of these out, and then we can get Colin to be, well, we can set him loose on them.
Fantastic, thank you. Hi, everybody. Colin, first question. Will this instrument work on powder coatings?
Yes. I'm just thinking of, yeah, I see no, I mean, it's going to pick up whatever it measures. So, I mean, if the powder coating has some angular, is it a texture powder coating or a very smooth finish? If it has no angular sort of dependency, it will just report back basically the same sort of colorimetric data at each angle. If it has a degree of directionality, then yes, I see no reason why it wouldn't. Again, it's one of the things that we as a supplier are applicating the instrument. We kind of get a bit of, it's the automotive industry's interested in multi-angle measurements, and we kind of think in that scope. But then you get things like cosmetics, which is obviously a lot of metallic finishes and pearlescence as well. So I think, oh right, it'll work in that. Powder coating, yeah. If anyone wants a demonstration, we're more than welcome when we're able to come and test it.
Indeed. Second question, is there an integrating sphere built into the device for color measurement?
No, if you think integrating sphere in 450, it is like a it works like a 45-0 instrument. So you've got 3 or 5, sorry, I'll start again. 5 detect illuminants shining at discrete angles, and you've got the detector at 45 degrees. So it is picking up whatever the reflectance is at an angle away from gloss, but it's essentially working in a direct illuminate and pickup angle.
Super. And somebody's been very, very vigilant and watching very carefully. So what is the Delta E Audi 2000 tolerance? There's a test for you.
Which I fail spectacularly. I don't actually know. I mean, I think it's like all, like all tolerances. The tolerance, I'd need to find the doc. I have got the specification somewhere, but I'm not sort of on first name terms with it, let's say. But as with all tolerances, it might be down to the individual user to set whether pass fail might be. It might be 0.2, 0.5, 1, or whatever. And it's like saying what is the tolerance on Delta E CMC. It will depend user to user, application to application. So I'm sure if we've got some contact details for that individual who asked the question, I'll dig out the spec and see if there's anything on tolerancing in it and let them know.
Super. And the same person, Sandra, thank you for the 2 questions. I'm actually, so Sandra has asked, how much does it cost? In terms of rough magnitude, in sterling, maybe sort of 15 to 17,000 pounds as the instrument, with the software as a sort of another sort of 10-15% on top of that.
Okay, so you were saying we do have everybody's contact details, Daryl and Colin, so we can, give those to you, and it does then enable Colin to get back to Sandra. And I think the same goes, there may be some of you watching who've got questions and you don't necessarily want to ask those questions live, or you might think of something after the event. Well, please don't worry, because we'll make sure that you've got everybody's contact details in both directions so that you can follow up these discussions separately. Colin, you were talking through the presentation about the challenges with, how many shades of black are there now? And you add in all these effects, the sparkle and the flip-flop and everything else. This was talking specifically about quality control. What about the challenges in terms of colour matching now for these?
Well, we're taking steps towards that. There is another kind of add-on to the EFX software, which is currently is labeled Auto Search and Correct, which is something we're kind of selling mainly to point of sale environments, where it's not a first level formulation system, but it has got a colorant database within it with a lot of set formulas, which then if a user comes back with a color which is close to an existing shade or is slight off shade, the system will correct it to the towards the standard. So it's like, almost like a traditional color formulation system. You've got formulation and correction. This one's kind of skipping the formulation step and going, we can correct from known formulas to given samples. The reason I didn't sort of touch on that within the presentation here is that it doesn't, the MA-5 QC doesn't at present work with that software. There is an MA-3, which is a 3-angle device, an MA-5, which is similar to the MA-5 QC, but with different firmware and software options on it. And our MAT-5, which is our point of sale version of the all singing, all dancing instrument, they all run with the Auto Search and Correct. And really part of that is in order to kind of differentiate the 2 products from an auto refinish shop who just wants a pass fail and a color check, and a company, whether it be a paint company or whoever who's got a paint system installed who wants to actually do kind of real life formulation. And I think I said when we did the previous presentation back in the summer, I think I got a similar question then. I said that color matching with metallics is the holy grail that we are certainly working on, and I'm sure some of our competitors are too. But what we're doing at the moment in terms of the Auto Search Correct software is driving down that path, and obviously the formulating for first principles will we'll be there one of these days.
Excellent. Well, I mean, it's fascinating to hear about all the challenges that we face. You know, there's no doubt that effect pigments, as you've just said yourself, it's not just, everybody thinks automatically automotive, but it really isn't. It's into cosmetics, it's into all sorts of other things now, you know, household appliances, etc. And so it is a challenge that you're facing. I mean, maybe going forward, thinking about this webinar forum, you know, perhaps we could allow you to do some more sort of visual demonstrations of some of these things next time at a stage when you can get back in your lab, when we are all not in lockdown and we are all more in a working environment. And I think that would also be, you know, really fascinating for us to see how some of these things are. But there is a lot of information in here, and I appreciate that when you're talking about specifications of equipment and all of these different criteria that they have to follow, it's a lot to get through, but you've done it perfectly as always. So thank you very much indeed for that. And thank you.
Pleasure.
We don't seem to have any more questions here, so I think, you know, we can move on now. So just to remind people that we have 4 more webinars remaining in our autumn series. So next week is a showcase by Leeds University. So Professor Long Lin, who is one of our trustees on the board of OCCA, but who also is responsible for the colour chemistry department at Leeds University, will be talking to us about what his students are doing at the moment, but also opportunities for companies to engage with Leeds in terms of any knowledge transfer, partnerships or research ideas and projects that you might have. And we then have 2 presentations by BASF Colours Effects at the end of November and December. And in between that, we have Bruno Bock Biochemicals. So just one word of advice to those of you watching who are not members of OCCA and who may be on these sessions for the first time. We have a special offer right now, and if people are interested in signing up to OCCA membership, if you sign up within the month of November, you would effectively get 2 years of membership benefits for the price of 1 year. Take a look on our website, have a look at occa.org.uk/sign up. And by doing that, it means that you would have access to all 25 of the webinars that we've been running since the end of May. And you would also get access to all the digital copies of our newly revamped Surface Coatings International Journal. So very well worth exploring. Without further ado, I'll leave you with our contact details on screen. If any of you have any further questions for Colin or Daryl or myself, either contact me at admin@occa.org.uk, or we will also be sending you a copy of the link to Colin and Daryl's presentation today with their contact details as well. So everybody out there, stay safe wherever you are, take care, and we hope to see you again, same time, same place, next Wednesday. Thank you very much indeed. Bye-bye for now.
Super. Bye, everybody.
Bye-bye.